students, I am your Komali Mam. In this session, I am going to teach you 6 best tricks. These 6 best tricks will help you to understand 6 best reagents. These reagents will help you to solve the questions like propanol, propanone. Suppose how you differentiate these two. Next, see the next question. Acetophenone and benzophenone. Which test will help you to differentiate? Phenol and ethanol, how to differentiate? Benzoic acid and ethyl benzoate, how to differentiate? Like this. Pentane 2-one and pentane 3-one, how to differentiate? Difficult, right? By seeing reagent directly within just seconds, how to identify that particular, what is that test? And how to answer it within just seconds you will find it. Watch this video up to the end. You will be able to learn total 6 best reagents. How many? 6 best reagents. What are those 6 best reagents? One is Tollens reagent and Fehlings solution or Haloform test, Tollens test, Fehlings test, Haloform test, aqueous sodium bicarbonate test, or neutral FeCl3 test and a Lucas test. These are the 6 tests you are going to learn in this session. Watch the video till the end. You will surprise the way you solve the questions. Okay. First one, Tollens test or Tollens reagent. What is a Tollens reagent? Ammonical silver nitrate solution, we call it as Tollens. So, ammonium hydroxide plus AgNO3. These two, if we mix 2 moles of ammonium hydroxide and silver nitrate, both combines and form this Tollens reagent. Tollens reagent, this is the formula. Okay, its name is diamine because 2 amine groups are present and silver is present here, silver. And oxidation state of silver in this complex is 1 and OH is present outside. So, it is hydroxide. What is its IUPAC name? Diamine silver 1 hydroxide. What is the use of this reagent is this Tollens reagent gives Ag2O, which means in this the reacting species is Ag+. What is the reacting species? Ag+ is the reacting species. So, when you add a Tollens reagent, Ag+ goes and react. Where it goes and react, this is an aldehyde. If you add this Tollens reagent, Ag+ will attack and it is an mild oxidizing agent. What do you mean by oxidizing agent? The substance which oxidizes aldehyde, which oxidizes other substances and it undergoes reduction. Itself it undergo reduction and oxidizes other substances. We call it as oxidizing agent. Here aldehyde RCHO oxidizes to RCOO minus and Ag+ will be converted into Ag. Here this Ag is black colored PPT, black PPT. Keep this black PPT in water bath. So, in a bowl of water, put this test tube which is having this black colored PPT. Then after some time, white color mirror kind of structure sticks to this walls of the test tube, which is the confirmation for aldehydes. So, here what you have learned, this Tollens test is used for the identification of aldehydes. Here one most simple and important trick I want to tell you. This is for Tollens test. Tollens is only for aldehydes. Aldehydes gives this test, whereas ketones don't give this test. Again, which aldehydes? Aliphatic aldehydes as well as aromatic aldehydes. Both will give the test. Both aliphatic, this is aliphatic, aromatic. Both gives the test. This is most important. Okay, aliphatic, aromatic, done. Next, let us see the second reagent, that is Fehlings reagent, and the test is Fehlings test. What is this Fehlings test is, we are having two reagents in Fehlings, that is Fehlings A and one more is Fehlings B. Ma'am, what is this Fehlings A? Tell me, what is Fehlings A? Aqueous copper sulfate pentahydrate, we call it as Fehlings A. What is Fehlings A? Aqueous copper sulfate pentahydrate. Fehlings B is sodium or potassium tartarate. Sodium or potassium tartarate. Tartarate. What is the sodium or potassium tartarate? Let us see. Tartarate. You know tartaric acid, this is the structure of tartaric acid. COOH, COOH, here H, here OH, here H, here OH. This is tartaric acid. From tartaric acid, just remove this H from here, remove this H from here. So H plus goes out, what will be left? CO minus, CO minus. Its structure is tartarate. Now, in this structure, I am going to keep one Na plus here, one K plus here. Then its name will be sodium potassium tartarate. This is called as Fehlings B. Now, you are combining this Fehlings A and Fehlings B. The combination of these two, what will happen? You know, it gives a complex like this. This is COO minus Na plus, COO minus K plus. This is one structure, right? This is one sodium potassium tartarate. Same way, one more sodium potassium tartarate, COO minus Na plus, COO minus Na plus. Now, here one H here, one H here. Then here oxygen, oxygen, because OH is there, right? That's OH. Again, same way OH, OH. Here all these four oxygens forms a complex with a Cu. This is actually the complex, but this complex, simply to say, it gives us CuO. Actually CuO, Cu2 plus is the reacting species. How in Tollens reagent Ag plus is the reacting species, here Cu2 plus is the reacting species. Now easily you can do it, see here, take a screenshot if you need. Okay. Now, here aldehyde I am going to take. What is that? Aldehyde. RCHO is the formula. We are adding Fehlings so that the reacting species is Cu2 plus. It reacts, it results in the formation of RCO minus, and Cu2 plus will be converted into what, students, tell me? Cu2O, where copper is in +1 state. This is reddish brown PPT. Which colored PPT? Reddish brown PPT. Reddish brown PPT. This is reddish brown PPT. Okay, is it clear? So same way how the Tollens is, here Fehlings also. But one important point I want to tell you. Here the easiest technique to identify is Tollens. How Tollens is the test for aldehydes, same way Fehlings also the test for Fehlings reagent, also the test for aldehydes. It gives a test for aldehydes, whereas it don't give the test for ketones. And Fehlings reagent, again aldehydes, aliphatic aldehydes, it gives the test, whereas aromatic aldehydes, it don't give the test. Tollens gives the test for both aliphatic and aromatic, whereas Fehlings gives the test only for aliphatic aldehyde like CH3CHO, CH3CH2CHO. Super, right? If you like this technique and you hit like on of this video, when you solve this question, this one point makes you to solve the question very fast. And see the next one. Haloform test. What is this haloform test? Most important test, these 6 are. What is this haloform test is? The compounds which are having CH3 C double bond O, either this or CH3. If you break this pi bond, what you will be getting? Break this bond, put one H here, one H here. So we will be getting OHR. So the compounds which are having either this part CH3 C double bond O or CH3 CHOH, either this or this, those compounds will give Haloform test. Rest of the compounds don't give the Haloform test. Okay, what is the major important thing? CH3 C double bond O or CH3 CHOH, these two only give the Haloform test. How to identify the reagent? For example, if they have given the reagent, how to identify is on the arrow must and mandatory iodine over NaOH, or we can also use iodine over KOH. If one H and one I goes out, we will get NOI, or if Na plus goes out, OI minus. Any of this reagent, you see 1, 2, 3, 4 in this any of the reagent, immediately you make an haloform. This is haloform. If this halogen is an iodine, then we say it as an iodoform, students. Is it clear? If it is an iodine, then we call it as iodoform. But here an important technique I am going to tell you, that is acids and acid derivatives don't give this test. What are the substances? Acids and acid derivatives don't give this test. Now see, for example, this trick you write in your book, easily you will do it. You don't need to copy also. I'll give the notes in the description. Just to download the notes and later you can. CH3 C double bond O R, right? So I'm going to put R place OH. R place OH. Then if I put R place OH, CH3 C double bond OH, acid it becomes. No. If you put R place X, then CH3 C double bond O Cl. Acid derivative no. OH X. If you put NH2, it becomes amide. If you keep there O C double bond O R, it becomes anhydride. If you put O R, it becomes ester. These groups should not be there in this R place. If it is there, even though the CH3 C double bond O group is there, it don't give the haloform test. Got it? And the next one is CH3 CHOH. So these molecule which is having these groups, it gives a haloform test. The molecule which is having this, but R should not be these groups. Acids and acid derivatives don't give this test. Crystal clear? This is about haloform test. Next one is sodium bicarbonate test. Most important. Aqueous NaCO3 you see. Which compounds you give, you know? Carboxylic acids. Whether aliphatic carboxylic acids or aromatic carboxylic acids, when you treat with sodium bicarbonate, aqueous sodium bicarbonate, it gives a positive test. Okay, fine. For example, you take sulfonic acid or aliphatic or aromatic sulfonic acid you take, students. If you treat with aqueous NaCO3, then it gives a test. Positive. Okay, but nitrophenols also, you take nitrophenol, phenol with nitro groups, it gives the test. But if you take only phenol, and you add aqueous NaHCO3, it don't give the test. What is that? Aqueous NaHCO3, it don't give the test. Because this is a weak acid, this is a weak base. This weak base cannot abstract this H plus from this and can't convert into carbonic acid, and later it cannot release CO2 gas. So they ask you the question, which test will help us to differentiate between benzoic acid and the phenol? So benzoic acid, aqueous NaCO3 gives the benzoic acid test, but phenol it don't give. Easy. Got the clarity? See the next one. Neutral ferric chloride. Which one will give this test? Is phenols, they give this test. Phenol. Take a phenol and treat with neutral FeCl3. Okay, if you add it, then it forms this complex. Okay, this is a violet colored soluble complex. Violet color soluble complex. Violet color solution will be formed. So indication, not only phenols, enols also gives this test. Okay, enols also gives which test? Neutral FeCl3. Which color will be getting, student? Violet color will be getting. Clear? This is about neutral ferric chloride. The last test is Lucas test. What is this Lucas test? Is reagent is concentrated HCl plus anhydrous ZnCl2. This is what? Lucas reagent. If you add this Lucas reagent to the alcohols, if it is a tertiary alcohol, the turbidity will be immediate, instant turbidity will be formed. Turbidity in the sense, the float of, some substance in the test tube you will observe instantly. If it is a secondary alcohol, you get the turbidity within 5 to 10 minutes. If it is a primary alcohol, you will get a turbidity after 30 minutes, around 30 minutes. Okay, this is about Lucas. Now, shall we start solving questions? Total, how many reagents you have learnt till now? Tollens reagent, Fehlings reagent, next one is Haloform reagent, next one is you have learnt sodium bicarbonate test, next neutral FeCl3 test, next one is Lucas test. Total 6 tests you have learnt, right? Now see how fast you can solve the question by using this technique. Question number. Give simple chemical tests to distinguish between the following pairs of compounds. From today, you no need to by heart what to say. If you see this chapter, this particular chapter is aldehydes, ketones and carboxylic acids, and alcohols also, alcohols and phenols questions also you can cover very easily. Propanol and propanone. Propanol and propanone. See, propanol and propanone, which is an aldehyde, which is a ketone. This is an aldehyde. This is a ketone. So which test you can tell me? Tollens test it will give or not? Students, tell me. Tollens reagent we can use. Tollens test. Aldehyde. But here no Tollens test. Fehlings test we can do. Fehlings test. Yes, we can. Fehlings reagent we can use. But for this, no. So the Tollens test you can use, or Fehlings test also you can use. And one more also, in this complex CH3, C double bond CH3 is there, so you can use, this is haloform positive, and this complex will give you positive, this complex will be negative because there is no CH3 C double bond O. So whenever for this question, if you read one book they give like this Tollens, one book they give Fehlings, in one book they give haloform. If you by heart and you read different books, there will be no use. But now, after knowing this, if you see any question also, okay, Komali Mam told, no, this is the information, you get the clarity. Next one. Acetophenone and benzophenone. Write the structure of acetophenone. CH3, C double bond O. This is the benzene structure. Okay. This is what? Acetophenone. Next, benzophenone is 2 benzene rings you put here and you write here like this. So this group is, both are ketones only. So it is having CH3C double bond O. So it gives a haloform. It gives haloform positive. It don't give haloform. This is one test. Okay. And one more test. This is Tollens reagent. Both are ketones, no? There is no chance of Tollens or Fehlings. That's it, only haloform. Very good. One test enough. They'll give you following options, which test you can use. Phenol and benzoic acid. Tell me directly, what is the test? What is the test? Phenol and benzoic acid. Benzoic acid, directly you can say aqueous sodium. Most important question it is. Most important. Benzoic acid, aqueous sodium bicarbonate, it gives a positive test, whereas phenol don't give this test. Phenol don't give this test. No. So by using that sodium bicarbonate, we can easily identify. Next question, phenol and ethanol. Phenol, draw the structure first, phenol, then ethanol. So neutral FeCl3, phenols gives the test with neutral FeCl3, ferric chloride, whereas alcohols don't give. Only phenols will give, alcohols don't give. Got it? See the next one. Benzoic acid and ethyl benzoate. Benzoic acid, what is the structure, students? This is a benzene ring, this is a COH, benzoic acid. And what is ethyl benzoate? C2H5, COO, here benzene ring. Or first I can write benzene ring, and then I can write COOC2H5. So this is an COH group is there. Whenever you see COH group, immediately you can say which test you can do. Sodium bicarbonate test it will give. So aqueous NaHCO3 test positive. This is negative. Is it clear? Is it clear? See the next question. Pentane 2-on, pentane 3-on. Draw the structure first. CH3, C double bond O, CH2, CH2, CH3. This is pentane, second position double bond O is there, pentane 2-on. Next, CH3, CH2, C double bond O, CH2, CH3. This is what? Pentane 3-on, third position. Now tell me which test, easily by seeing only you can say, ma'am, pentane 2-on, right? So it gives the test of haloform, because both are ketones, you can't use Tollens or Fehlings. So CH3, C double bond O is there. What is this? Haloform. This is haloform. This is positive. This is negative. Why, ma'am, this is negative? Because CH3, C double bond O adjacent is not there, so it is not useful. Next, benzaldehyde and acetophenone. Can you tell me? Benzaldehyde. Come on, say benzaldehyde. This is acetophenone, C double bond O, CH3. So what test it will give? This is an aldehyde. This is a ketone. So ketone means Tollens will give this test? No. Tollens will give this test? Yes. Tollens reagent. Fehlings is useful? No. Even though it is aldehyde, Fehlings is not useful. Can you tell me why Fehlings is not useful? Because in case of Fehlings, only aliphatic, aromatic it don't give. That clarity, see how much important? Easily, if you know this point, how fast you do, you know. Next one, Fehlings is not useful, both the cases. Next, C double bond O, CH3 you can see. If you see this group, then haloform, positive. If you use haloform test, then it don't give the test, it gives the test. So in such a way, by using these two tests, you can identify very easily. Next, ethanol and propanol. Can you try this? Ethanol, CH3, CH2, CH3, CHO. Next one is CH3, CH2, CHO. Okay, try ethanol and propanol. How to identify? Try this. Come on, students, this is ethanol. You can see which test it is. Which test it is? Both are aldehydes. So Tollens and Fehlings, for both it will give. You have to differentiate. How to differentiate? CH3, C double bond O is there, means it is an haloform test. So it gives haloform, it don't give. Next, propane 2-vol, 2-methyl propane 2-vol. Propane 2-vol. See how I am going to write? Propane 2-vol. Next one is 2-methyl propane 2-ol. So this is the structure. OH connected to the carbon, that is connected to only connected to two other carbons, so it is a secondary alcohol. OH connected to the carbon, this is connected with 3 other carbons, so it is a tertiary alcohol. So Lucas test is Lucas reagent. It gives instant turbidity. Instant. It will give turbidity after 5 to 10 minutes. In such a way, you can differentiate between the both. Next. Over. Like this, you can solve n number of questions based upon the 6 best reagents. These reagents, practice one time, you will be able to solve the questions very easily. My name is Komali, I am your chemistry mentor. Thank you so much for watching this video. If you are watching for the first time, please subscribe to Komali Mam channel for more best videos. Like and share to your friends also. Thank you so much. Bye. See you again in next class.